Okay, how much must Ariana deposit at the beginning of every 6 months for 7 years into an account at the TD Canada Trust at 7.11% compounded semi-annually to accumulate $175,000? All right, so the deposit is at the beginning. All right, at the beginning of every 6 months. So let's choose begin here. And then it's every 6 months the deposit. So it means TY will be 2 or twice per year. All right, now the compounding is semi-annually. So TY will also be 2. Right? What else is there? Well, the present value here would be 0. And we would like to find the deposit. Okay, how much must Ariana deposit? So the payment is what we are after. The future value should be what? Well, it accumulates 175,000. So this future value here should be $175,000, okay, which we will insert right there. And the interest rate is 7.11, which is this number right up here. Okay, so there we are. So let's begin. Okay, begin mode, so second PMT and end. We change that by clicking on second, enter, and there it's the begin mode. And we can exit or quit through second CPT. Now let's start to enter PY and CY. They're both 2. So second IY and 2 enter for PY, and CY is also 2. And we can exit either here like that, or we could have gone down here. All right, so next is the calculation of N. Now this is for 7 years. So there we are. We have the 7 years, second N, N. And N turns out to be 14, which is this 7 years times this 2 here. That is giving us the 14. Next is the interest rate, which is 7.11. We put that in 7.11, and that's IY. Present value is 0. Right? It's starting to build up or accumulate the $175,000 now. 175,000 is the future value, and we can compute the payment. And that payment turns out to be, we can use the negative sign if we so wish to do, $9,524.22. Right, and hopefully all of that is correct. We check our answer and it is correct. Now, as usual, this will take a positive or a negative value. And you see it does. All right, the next question. Aitana is purchasing property worth $1,480,000 with a down payment of $503,200 and a quarterly payment. All right, at the end of every 3 months for 30 years. If the interest rate of 3.27% compounded monthly, if the interest rate of 3.27% compounded monthly for the 30 years. All right, so what is the amount of each payment? Now, the payments are what? The payments are the end of every 3 months. So that means it would be 4 times per year, or as it's states right here, it's quarterly. All right, the compounding is monthly. See, the 3.27 is compounded monthly. So we put in 12 for CY. We pass over N. IY is 3.27, as we can see it up there, 3.27. Okay, present value, we will have to compute that from these two numbers right up here. And what are they? Well, one is 1,480,000. So we can go 1,480,000, 000, and subtract the down payment of 503,200. 503,200. And we get this number here. And of course, since we've computed it, that is indeed the present value. So $976,800. And if we wish, we could put in the decimal 00. Now the payment is what we wish to compute, because what is the amount of each payment? So that we will compute, and the future value should be 0 because the property should be paid off. All right, so let us go and begin. Now, we are supposed to be in end mode, so we must change that begin by clicking on second PMT. There is begin second, enter will put us into end mode, and if we wish, we could come out by just clicking clear, and we're out of the menu that has begin and end. Now we begin by entering PY as 4. So second IY, PY is 4, so 4, enter. Then we come down to enter CY, and we see that CY is 12. So 12, enter. CY is 4, CY is 12, and with that we can come out of here. We can just click on clear, and we can clear now once more if we wish to get rid of the 12. Now this is supposed to go on for 30 years. So 30 years is used to calculate N. So 30 times 4 gives us the 120, which you must be careful about. 30 is multiplied by 4. That is the reason for using second and N. All right, that clears up the choice of what number it multiplies by. So 3.27 is the interest rate, 3.27. Present value is this amount here, which we calculated before. Now let's recall present value, and it is $976,800. Payment is what we'd like to compute, and the future value is 0. So 0 for the future value, and we compute the payment. And the payment turns out to be, let's put it here, it's negative. We can use the negative sign if we wish, meaning payment is you're paying out, and $12,820.35. Now, what is the cost of financing? Well, the cost of financing is what? You have to take the total amount paid, and subtract the present value, correct? So here we go. So we have already a setup there, and we can make use of it by going here and getting the amount. So how much is the payment? Payment is this amount right here, $12,820.35. So that is the payment. And then we multiply by the number of payments, which is 120. So 120, and then we subtract the present value, which is $976,800. So there we are. And we should come up with a result. Let's see what happens. Okay, so let's get the calculator, and we can do some calculation. We have the payment up there, but we can enter it manually. 12820.35. That's wrong. It's 2 decimal places. And we multiply by, we could have recalled n or just multiply by 120 because we know what the number is. And that is the amount we end up with for the amount paid or the total paid, $1,538,442.00. Now we subtract the amount that was borrowed. It was 976,800.00. So now we have the amount that's paid. We can now subtract 976,800, and we could put in 0.00, and there we are. That is the amount of interest that, or the cost of financing or the interest paid. It's the same item or same amount we're referring to, and there it is, $561,642. Okay, so there we are, 561,642.00. And of course, it says to enter a positive value, which we just did. We check our answer and everything is well. So that is very good. We did it correctly and we're very pleased. And we can now move to the next question. All right, so let's go to question number 15. Okay, Paul is converting an RRSP balance of $275,000. That would be what? Well, that would be a present value, right? Yeah. Into an RRIF, Registered Retirement Income Fund. So this was the Registered Retirement Savings Plan. Now it's time to receive income. Paula wants to receive $1,305. So that is an amount that is being received. You can put it in as a payment at the beginning of each month. So begin mode, and each month, so means PY is 12 for 23 years. What nominal annual rate of interest compounded semi-annually is required? It's compounded semi-annually, so CY will be 2. Round the answer for IY to 2 decimal places. So the future value will be 0 because after 23 years, the fund will be exhausted. This $275,000 would have been completely gone. Now this is what we would like to compute, and that is the interest rate. Okay, so let's go. We have to go to begin mode. As always, we should pay attention to what we're doing. Beginning is in bold, so we should go second PMT, second enter. And we can get out of there by just clicking on clear or second CPT, and we are finished. And we are in begin mode. So PY is 12. Let's enter it. Second IY, PY is 12. So 12, enter. And CY is 2. So 2, enter. And we can check. CY is 12, CY is 2, and we can come out of there. Now, how long is this for? Well, 23 years. So that enables us to calculate N. So 23 second N, and N turns out to be 276. All right, what is the interest rate? That is what we'd like to calculate. Present value, $275,000, 275,000. And we put that in for the present value. The payment is 1305. Now we can put it in as positive, or you might wish to put it in as negative, as is the custom when you're paying out. Now let's say we did put that in as positive, right? And we put 0 for the future value. Why positive payment? Because it's being received. And now if we compute IY, we will get an error of 5. And that error of 5, it is because these two values are the same sign. If they're both positive or both negative, it will result in an error of 5. So you can decide to either change the present value because the Paula doesn't have the money yet, and leave the payment as positive. So let's go back and recall the present value, make it negative by hitting plus minus, enter it by hitting PV and computing IY, and there we have the answer. And the answer is rounded to 2 decimal places would be 2.49. Correct? Rounded to 2 decimal places, and we can check our answer, and there it is correct. Now remember we made PV present value negative. So let's say we make it positive. And let's recall the payment and make that negative instead. And we compute IY and we get the same answer. All right, so that is how it works there. So those signs have to be opposite, meaning present value and the payment. All right, I think that covers what needs to be covered there. And they can go to the next question. All right, so now we have a loan of $43,770, and that would be a present value. There, it's repaid by making payments of $470. Now we are making payments, so we would normally put it in as negative, right? And it's at the beginning of each month. So let's go and select begin. Interest is 7.1% compounded monthly. So it means that CY is 12 and the interest is 7.1. Now, what is PY? Well, payments at the beginning of each month. So it means PY is 12. All right, so what do we need to calculate now? How many payments are required to repay the loan? How many payments are required to repay the loan? So that is N. N is where we need to do a computation right there. And let us start. Now we're in begin mode, so we are safe. And we can start entering the values for PY and CY. So second IY, CY is 12, or we can indeed enter it, 12 and enter, and that is also for CY. And we can exit or quit. Next is to find N. Well, we are computing N in this case. So we pass over N and we go to the interest rate of 7.1%. Now the present value is $43,770. So 43770 is the present value. And the payment is $470. So 470, make it negative payment. And of course, 0 for the future value because the loan should be paid off. So 0 should be in there. Okay, so now we compute N. And we get 134.5178.425. Now, it says rounded to 2 decimal places, so we will stop at 2 decimal places and put in 134.52. All right, that's 2 decimal places. Now, the number of payments, it has to be an integer, so you have to round to the next higher whole number. So we're past 134, so in here we should put the answer of 135, and hopefully that is correct. Check our answer, and it is correct. All right. So next question. I think this is the last question. Which of the following end of period payments will provide the largest future value to an investor over a specified term at the same positive interest rate and compounding frequency? All right, good. Now, these are end of period payments, so please be careful. We must move the calculator. Let's get it into end. So second PMT, second enter, and that puts us into the end mode, and we can come out of there by clicking on the clear button. All right, so we want to provide the largest future value. Okay, the interest rate is the same and the compounding frequency is the same. So what does that mean? Well, it means that we can choose any value for the interest rate, right? So let's copy the question and let us paste it into here so we can have a good perspective on what we would like to do. Now we might as well get this to a larger font, and while we're in here, maybe we'll just change it to, let's go to 16 so we can see it really clear now, right? Now, what do we want to do? Because it's the same positive interest rate, that is one item there, and the compounding frequency is the same. Okay, so let's use a different color, maybe the turquoise. All right, good. So what do we want to do? Well, we have to choose. We can choose, we choose it, okay? So we decide what we want. So we will make a choice. So we choose IY as equal to what? Interest rate, let's say 10%, right? And then we will choose the compounding frequency. So that means CY. We will choose it to be, let's say we choose it to be 1, just to be simple. All right, so IY is 10 and CY is 1. Okay, now we can start to evaluate these different scenarios, right? So let's go. So the first one is $250 monthly. Okay, so what happens there? All right, so we're computing the future value, right? We'll do it once and then we will just put the numbers in. So let's go. We need a calculator, of course. So we will pop the calculator up and we'll move the calculator over here because we can see the payments. We can just move this and we can get to whatever we wish. All right. So now we put in the payment. It's monthly. So maybe we should put here that monthly. So it means that TY is equal to 12, right? And then we push that over a little bit. So PY is 12, so that one is set. But we'll keep CY and at 1. Enter, so CY is 12, CY is 1, and then we come out of there. Now, end of period payments, largest future value. So we need the number of years because it's over a specified term. All right, so that term is specific. I mean, it's some number. So we have to make a choice for that also. So why don't we do that? Maybe we can do a little bit of squeezing there so we could access the calculator easily like that and then put it away easily also. So what are we doing? Well, TY is 12 as we found out right there, and TY we put it as 1. So we have to put in for the number of years. So what we will do here is to put in a value for the number of years. The number of years let's put it equal to, well, let's put 10. So there's some significant amount of difference that will be generated. So let's say we put 10 years, so 10, second, n, n, so n is 120. The interest rate is 10 as agreed upon. All right, we should maybe highlight these. This 10 is going to be consistent, meaning it will be the same, and the number of years is 10. Also, you're just choosing numbers that are simple to work with. So 120, we have no problem with that. Interest rate is 10, so we will put that in for the interest rate. The present value is what? Yeah, that's 0. 0 for present value, so we should probably put that in somewhere in here maybe, so it will be visible. All right, so present value is 0. And the payment is 250. So 250, let's put it in as negative payment. And we're always computing the future value. And this works out to be, okay, so we round to the nearest cent, $49,965.96. Okay, now let's go to the next one. $750. So next one is $750, and it is paid quarterly. So that means PY is equal to 4, right? And similarly, we go and we compute. We're computing the future value, and that would be equal to some number. So let's pull the calculator up again. Now, PY is now 4, so second IY, we put 4 for PY, and CY always remains at 1. Okay, so then we're finished. PY is 4, CY is 1. So we come out of there, and 10 years, remember we decided 10 years, so 10, second, and n is now 40. Now the present value is still 0. That will not change. The payment changed to 750. Okay, so now we compute the future value and we get $49,569.64. Right? So that's our second one. Now next one, $1,500 semi-annual. Okay, so now we come down here and we have $1,500 semi-annually. So what does that mean? Well, it means that PY is equal to 2. And then we have to go and compute the future value, and that would be equal to some amount of money. So let's go back in there now. PY is 2. Enter. And CY is 1. Enter. All right. Okay, so we come out of there. Sorry, maybe we should check. PY is 2, CY is 1. There we are. Okay. And we went for the 10 years. Remember, this 10 years is everything has the same amount of years to make the comparison, a proper comparison. So N now is now 20. The interest rate remains the same. Okay, it is, sorry, I did something wrong there. So 10 is the interest rate. That should not change. Okay, so it is 10. Now, what else do we have? The present value is 0. Yes, this is 0. This present value is 0. There'll be no change here. So we can recall the present value, and it is 0. The payment is now $1,500. So we have to put in $1,500, right? So 1500 negative payment, compute the future value, and we get an amount looking like $48,979.10. Okay, now next one. $3,000 payment annually. Okay, so $3,000 annually. Now let's come down here and $3,000 annually. So that means that PY is equal to 1, and then we compute the future value, and that is equal to some number. Okay, so now let's go in second IY, so PY is 1. Enter, and CY will also be 1, which was agreed upon originally at the very beginning. So PY is 1, CY is 1, and we come out of there. And the number of years is 10. So we go this 10 right up here. So 10, second, and N. And IY should be 10. So let's recall IY, and it is 10. Recall the present value. That should be 0 also. But the payment is $3,000. So 3,000, make it negative, enter the payment, and then we compute the future value, and that is the amount of the $47,812.27. So which return is best? Well, it seems as though this one is the return that is the winner, as we can say, because it has the largest amount, $49,965.96. Right? So the answer should be $250 payment monthly, and we check the answer, and our answer is correct. Green border, green check mark, and 10 out of 10. Now, say you had no time and you wanted to guess at which answer will probably be correct. All of the above is definitely wrong. You can see that it so happens that the one with the most frequent compounding is the one that yields the highest, the largest future value. Okay? All right. But of course, it's dependent on these amounts that are being entered here, or the amount of each payment. Correct? Yes. But anyway, so that is the correct answer. And that brings us to the end of the question. I will stop the recording.